Welcome to PyCon, and thank you for coming to my talk on Dask-SQL, empowering Pythonistas for scalable end-to-end data engineering and data science. My name is Adam Breindel. I look a little bit like this, at least before COVID gave me an even worse haircut. I looked like that. I have some contact information in the presentation here. You're welcome to connect to me. And I work as training lead at Coiled Computing, a Dask in the cloud startup focusing on making it easy to scale Dask. I also do some work on data engineering and machine learning as a consultant. Do some software development and a few other things. I've been doing this for a ridiculously long time, over 20 years. And I have a little bit of other information about some of the things I've worked on before, but I know we're all here to learn about Dask and SQL and not so much about me. So I want to get right into the really exciting topic here. So first, just to kind of orient everyone, in case you're coming from one of the many other corners of the Python world and not the large-scale data engineering corner. What I've got on this picture here is a sort of simplified model of a typical large-scale enterprise data processing pipeline. So this might involve lots of different tools, so it's not a single program. This is sort of a high-level architecture. And the idea is that over on the left-hand side, we have a bunch of data, typically sitting in some kind of a data lake, although there's a few other options. And when we want to do things with that data, we need to pull it out. So we need to kind of locate it, pull out that data, figure out how to process it. Usually it's not exactly in the form that we want. Even if it's in the format we want, we usually need to mess around with that a little bit. So there's this transform step. If you're thinking about producing a report, that might be kind of transforming and aggregating and rearranging the data to get closer to the business information you're trying to report on. If you're on the machine learning side of things, this might be creating customized features or standardizing and cleaning up features. So there are a lot of things that we might be doing in there that get us from raw data to some data that's a little bit more usable for whatever the next step is in our project. So sometimes after we rearrange that data and transform it and clean it up and merge different files and all of that, we write it back out. So that's kind of this path on the upper right here. So sometimes we do that and we're finished, and sometimes it's automated. We set this up and this just goes. Other times we're going to analyze that data and we might produce some reports. So there might be some human-generated reports, some automated dashboards. There might be some routine that produces reports on an ongoing basis and ships them off to our partners. And then there's also the machine learning modeling, where we might take some of that data that we've analyzed and apply some machine learning to it to try and build some model that we can later deploy into production to help our business in some way. Now, there's a few more steps on here that are not on here, that are not in the picture. So before we even get the data into the data lake, there's a lot of challenging upstream work in terms of acquiring data and ingesting it, and we're not going to get into that part today. And also, there's very important things downstream. So when we have some reports or some models, those things need to be deployed somewhere and they need to be monitored, and there's a lot more over there. But today we're kind of zooming in on the core of this process, and specifically some of the steps I'm going to look at on the left-hand side of this picture, because that's really where SQL is most important and where it's been difficult for Python folks in the past. So about a year ago, I was talking a lot about Dask and using Dask for these enterprise large-scale data processing pipelines. And over on the left-hand side here, we have Dask APIs that can do a lot of these steps. So they can retrieve data in various formats. They can use friendly APIs to rearrange that data, and then we can feed that into subsequent steps. However, that required, at least last year, required using Dask's regular APIs. Now, I'm a big fan of Dask's APIs. I think they're pretty friendly, pretty easy to learn, and pretty easy to use, but not everybody in the world is a Python programmer. And sometimes, even if we are a Python programmer, we may be asked by our boss, let's say, to retrieve data where we already have existing SQL. Right, so SQL is kind of the lingua franca of the data world. Probably more people know SQL than any other individual data relevant language. I can't prove that, but I have a pretty strong feeling that it's the case. And SQL allows us to span different eras of technology. A lot of times we have queries or reports that we need to implement where that SQL was written 5, 10, 20, 30, even 40 years ago, and that stuff is still important. So SQL kind of bridges across technological eras. It also bridges across business functions, right? We have business analysts that know SQL, but they're not programmers. We might have programmers from other language kind of ecosystems, and they don't really know Python, but they do know SQL. So there's lots and lots of uses for SQL, and lots of places where in order to implement the existing business process, we need to use SQL. So it's not, in theory we could rewrite some of that, but if a company has thousands of scripts that are hundreds of lines of complicated SQL each, it's unlikely that they're going to want to rewrite all of that and then test it for correctness and all of those things. So SQL is really, really important. And a year ago we had this whole kind of nice picture, and over here on the left we had Dask, but we did not have SQL. So if we needed SQL, we needed to use other tools at the time. So what we talked about at that time were integrating JVM-based tools. So these are things like Spark, Presto, Trino. These are tools that are kind of come from the Java-based big data world, and they know how to apply SQL over these collections of files. But that's not always very easy to work with if we're coming from the Python point of view. A lot of times it's the Python APIs for finding the pieces of data that we need can be really, really tricky, and it can kind of push somebody maybe out of their specialization kind of into a data engineering role that they're just not really used to, and it's not their main job, and then it's very difficult to succeed. So luckily, it is not 2020 anymore. We're all happy now, I think, that it's 2021. So not everything is perfect, but things are improving. And one of those things that's improving is we now have a thing called Dask-SQL. So what is Dask-SQL? Well, it's in one line, it's Dask plus SQL, but we're going to get into a little more detail in this talk. So what we can do now is do all of this work on the left-hand side of the picture using SQL. We can even do some of the stuff on the right-hand side of the picture using SQL, but we're not going to Dask-SQL, but we're not going to get into all of those details here today. So, okay, so what is Dask-SQL exactly? So the one fundamental headline here is adding SQL execution and Hive access to Python. The picture here is a gentleman named Niels Braun, and he works for the Bosch Center for Artificial Intelligence in Germany. He is the lead on this project and created this project. I've got a link to his LinkedIn and the GitHub, his GitHub down here. And what does Dask-SQL do? So it does quite a lot, even though the project is less than a year old. So first we'll look at these core features. SQL parsing, optimization, planning, and translation for Dask. Basically, take SQL, make it run on Dask, and we'll talk more about how that works in a bit. It lets us start with data from lots of places. There could be files in the cloud, right? So pretty much any cloud, for example, S3, but lots of other places that data could be. Any data you already have in Python. So you have Dask data frames, well now you can do SQL over those. Even if you just have a bunch of pandas data frames, we can work that into this picture as well. There's some new support for modern catalog and aggregation systems like Intake. Intake's a really neat project if you haven't had a chance to play with that yet. One of the most important pieces here, especially in terms of empowering Pythonistas in the traditional enterprise data world, we can read data directly from enterprise data lakes or warehouses where the catalog is typically stored in something like the Hive Metastore, Databricks catalog, and so on. That's a really big deal because if you're coming from the Python world, and you show up at your new job at some giant company, and they say, "Oh, we're so happy to have you here. Your first project is this really simple, a linear regression," and you're like, "Oh, great, I can knock this out of the park." And they go, "The thing is, you're going to need to join these 17 tables, and they're built out of views over all of this data in our data lake." And then things start getting a little murkier, and then you kind of dig into that, and they say, oh, it's no problem. All of these tables are defined in the Hive metastore. Just go grab the underlying data, and you're good to go. It's not quite as straightforward as that. But luckily, DaskSQL is going to make that really, really easy. There's a few other great features we've got here too. So we can, just like we can normally do with Dask, we can cache data sets. So if we have a big pool of servers, a big cluster, we can cache those, cache the data in there and use that for our work. And there's a bunch of kind of what I've called bonus features, which will maybe eventually be core features, but they're maybe not the headline today, and those are things like user-defined functions, a SQL server that allows folks using reporting front ends like, say, Tableau to be able to pull directly from your Dask system. Machine learning in SQL. So that's something that's slowly getting more popular, and there are options for that already supported in DaskSQL. A command line client, so you can run SQL directly from the command line, and even more that's currently in the works. So I've got a few links here. The home page for the DaskSQL project. So it's brand new, really shiny, nice, quick start home page for the DaskSQL project. There's also full documentation linked down here, and the GitHub repo, of course. So we're going to do some coding, but before we do our code demos, I want to make a little clarification. And if you're a veteran of the big data world, this is kind of, you can grab an extra cup of coffee and come back in a minute. But for the folks that are new or just haven't spent a lot of time in this large-scale data engineering world, this can be a little bit confusing. A lot of questions that I get around DaskSQL, folks say, well, wait a second, but doesn't Dask have a read SQL table already? Doesn't Pandas have a read SQL and a read SQL query? And then I've got SQL Alchemy. I've been using Python with SQL Alchemy for a long time. How is this different? Why do we need something new? And so it's worth clarifying this. So those systems are all very, very different from what we're trying to do here with DaskSQL. And the difference is this. Those other approaches allow you to formulate a query, and they pass it to a database system which already understands SQL or a similar language and can execute that query, and that other system has control over your data. In other words, they pass a query to another system that already knows where all the data is and can do all of the work. So there's a big challenge when we want to apply SQL to these enterprise data lakes. Now there are other tools that have supported this use case and have been very successful in the past. So you've probably heard of systems like Hive and then Apache Spark. And those are great tools, but they're based on a kind of a Hadoop JVM system. They're kind of becoming a little bit legacy tools, and in any case, they're not necessarily the easiest things to understand, optimize, use, all before you can start your work in Python. Right, so those things can be an obstacle. The goal of DaskSQL is to allow you to formulate a SQL query against arbitrary files and formats, and then execute that query at large scale using your Dask cluster. And this is going to help us put all of that together. Okay, so it is coding time. Let's go and demo a few different fun things here. We're going to demo 3 approaches to using DaskSQL in the little bit of time that we've got. First, we're going to show creating a Dask data frame over a set of files, and then using DaskSQL to query that. Then we're going to create a DaskSQL table completely within SQL, which is something that might be really popular with your SQL analyst friends or folks that are maybe used to a more kind of Hive type approach. And then the third example is we're going to show using DaskSQL to access tables already defined in the Hive catalog. But we're going to do the actual query execution using Dask. So that's really kind of the golden ring here, because in that story where you show up to your new job, this is what you really want. You want to be able to say, okay, no problem. I'm going to write my SQL. I'm going to reference these tables. Those tables are defined in the Hive catalog. But I'm going to find all the underlying data without having to do the work myself, and I'm going to execute my queries against that using my Dask cluster in Python. So these are the 3 things we're going to look at. So first I'm going to spin up a little Dask cluster with the distributed scheduler here. And let's just make sure that that is alive over here. So this is the Dask dashboard. We'll look at this once or twice just to make sure things are actually running in Dask. Now we're going to spin up a Dask-SQL context object. And in this first example, remember, we're going to start with a Dask data frame. So this is a Dask data frame built over the UC Irvine power plant data set. So it's a simple data set around power plant measurements. You can see here it's got 5 columns and they're all floats. And what I'm going to do is I'm going to register that data source with Dask-SQL, and I'm going to call it power plant. So when I say call it, I'm going to create a virtual table name in the Dask-SQL table space called power plant. And once I've done that, I can run SQL against that table. So here's a pretty simple query, a select star, and we get basically the same sort of result that we got from just looking directly at the underlying data. So this is pretty much the same view. You can see there's a little bit of a different task graph involved. I'm not going to get into the details there today, but we're looking at the same data. The results, the default results from a Dask-SQL query are a Dask data frame. You can see that here. Like any other Dask data frame, if it's sufficiently small, we can compute it and get back a pandas data frame. Now, if we don't want to go through those 2 steps, and we know that the query we're doing is not going to return too much data, we can pass this parameter, return futures false. So I can say Dask-SQL context, run this query, don't give me futures, that is, don't give me a delayed execution, just give me the actual data. And you can see here that comes back just as a regular old pandas data frame. So there's a lot we can do with this. We can write maybe a little bit fancier query. Maybe if we're interested in looking at the relationship between the temperature and the power output in these power plants, maybe we kind of discretize the temperature a little bit here. And we can get a table of temperature and output values. And if we compute that, we can then plot this using regular pandas plotting. Now we could do even more with this data. Maybe you look at this picture and you say, we could do an interesting regression model with this. You actually can do a lot with machine learning and Dask-SQL. And there's a documentation page on here if that sounds interesting. We're not going to get into details of that today, but it's a pretty interesting set of capabilities. But I want to move on to my next example. What about creating the table completely in SQL? Right, so we're not going to write any Python in here. But we're going to be using Python systems to do this execution. So there's Python behind the scenes. So the Dask-SQL context has a method that installs an IPython magic, and now we can go %SQL, and we can just put our SQL right here in the notebook. And if I run this, I'm creating a table. This one's called all SQL, since we're doing all SQL today. And I have a couple of keyword values in here. Format CSV, location points to a location of any Dask accessible source or format. And now, if I run that query, this time against my all SQL table, right, we get the same output here. And now we're working completely in SQL, but again, we're using Dask behind the scenes. So all of that execution is happening in Dask. Now our third example is Hive catalog integration. But what we're going to do here is we're going to create a cursor that points to the Hive service. And then we're going to create a table on our Dask-SQL context. We're going to call it My Diamonds. And it's actually going to point to a table in the Hive catalog called Diamonds. Now, when I run this, a query is going to run against the Hive server just to describe the table. And you can see that over here. So if I refresh this is a Hive server page. If I refresh this, you can see that we just did a describe formatted on Diamonds. But what I'm claiming here is that if we run lots of queries over this Diamonds table in Dask-SQL now, you won't see any more queries in Hive. We're not using Hive anymore. Hive is just telling us where the data lives, but we're going to do all of this stuff in Dask and Dask-SQL. So Here we've got a query to pull up the first few rows. And here's a little kind of more interesting query where we're going to kind of look at our diamonds in tenths of a carat, and we're going to calculate the average price for each of those tenth of a carat intervals, and we'll also see how many diamonds are in those intervals. So we define a query. We're going to go ahead and run it just like we did before. Context.SQL query. We're going to do a compute to get a data frame that we can plot locally. And we get this nice set of diagrams here. So one thing you can see is that in the diamond data set, this is the ggplot2r diamonds data set, you may have seen it before, there's lots of small diamonds that show a really nice correlation between carat weight and price until you get to about 2.5 carats, and then that relationship starts to come apart for a variety of reasons, and one of them is that there's just not a whole lot of data up there if you look at the right-hand side of this bottom graph. So these are just the kind of things that we can now really easily do, and we can share with our analyst and SQL friends. So let's spend a minute or two talking about how Dask-SQL works. So these are the steps when we're doing something with Dask-SQL, and as you've seen, most of this happens automatically, but this is what's going on under the hood. First, we need to locate the data source. Right, so this could be Hive, like we just demonstrated, or some other catalog integrations, or it could be files or Python data that comes from the user. We then need to prepare the query, and that's done using an open source project called Apache Calcite. So the actual query parser, optimizer, and sort of a relational algebra engine is actually done in Apache Calcite, which is a wonderful open source project. That's actually implemented in Java, but it's kind of hidden away, so it just so you don't need to directly deal with the Java bits of this. And that goes through some standard phases of query processing, so kind of parsing since we're starting with strings, analyzing to make sure that the right tables and columns exist, optimizing using a set of different mechanisms to potentially improve the query, and then we need to create an execution plan. And this is where Dask-SQL takes over from Apache Calcite, and it takes a structure of logical relational operators, things like projection, which corresponds to the SQL select, or filters, that correspond to the SQL where, and so on. And it converts those into Dask data frame API calls, right? So maybe they become a dot query, maybe they become a dot merge, and that is a big part of the magic of Dask-SQL. Dask-SQL can then do one of two things. It can return a handle to the Dask data frame of results. So that's what we saw in the very beginning. You get it back a Dask data frame. So this is a virtual data frame, right? We've got metadata, but we don't actually have the data. It's kind of delayed execution. Or we can say, hey, we just want to run this right away. So that's where we said things like return futures false, or where we use the %% SQL magic, and we execute the resulting data frame and return the results right away. So either as a pandas data frame, or just directly out to the screen with the notebook magic. There's a little bit more detail on all this under the hood processing, including how you can see some of the query planning in action if you're interested in that, over at this doc page. So we have just a minute or so left, and I want to offer a couple of practical details as we finish up here. So how do you install this thing? Well, there's a doc page that explains that, but basically, if you're used to using Anaconda or a variant like Miniconda, it's just a Conda install. So it's on Conda Forge, and it brings in all the dependencies, including the JVM, and that all just works. It's really nicely put together. What kind of SQL can I use? Right, so you're probably thinking, well, SQL is an enormous language these days, and Dask-SQL is a young project, so there must be something missing. And of course there is, right? Not everything is there yet. The details on that are on these pages. So things like query support, table creation, so loading data, and that machine learning via SQL down here. How can I contribute? There is source code and info on a development install on the GitHub page. Of course, there's a Dask-SQL GitHub issues list, so you can see what's broken, or if you break stuff, you can file new issues. And there's even a good first issue list if you're not sure where to start. So thank you very much for checking out Dask-SQL. I hope this is useful and allows you to do even more with Python. Thanks.